All right, I think we're going to get started here in a sec. So if you want to take your seats. This is the talk on Kubernetes security best practices. So this is going to be a talk where I'm going to talk about some low-hanging fruit and some simple things that you can do to help improve the security of your Kubernetes cluster, as well as some towards the end a little bit more complicated things to and things that you might think about implementing to kind of overall improve your security posture. So my name's Ian Lewis. I am a developer advocate at Google Cloud based in Tokyo, Japan. I focus on Kubernetes and particular container security, but I have a background developing Go and Python applications as well. I've been around the block doing development in past lives. So I want to kind of level set a little bit at the beginning here and just kind of talk a little bit about how I see Kubernetes itself. Folks describe it as a container orchestrator, but ultimately what it's kind of doing is providing an API where you consume infrastructure, and as part of that, you're consuming this infrastructure, and part of that API gives you features around the security of that infrastructure. And so part of this talk is around what sort of features are available to you and what sort of things you can take advantage of as part of that in order to improve security. So that's how I kind of like to think about Kubernetes in terms of some of the security aspects of it. And today, to kind of talk about the agenda for this particular talk, security is kind of a big topic, and you can cover a lot of different things. So what I want to do is just kind of scope the talk here a little bit. These are the things that I'm going to talk about. I'm going to talk about, give a little bit of the background to level set a little bit more, talk about security 101, and some of the ideas and concepts behind how you think about security. And then I'm going to talk about how to improve runtime security of clusters, improving the security of the host, so basically your workers, your kubelet servers, the network security, and then just kind of wrap up there. So some other topics that you might want to explore after this talk and research are things like threat detection, detecting when somebody's compromised your cluster, things like build hygiene, so your how to secure your CI/CD pipelines, things like that, how to make your images a little bit more secure, how to limit the attack surface on images, as well as operations, how to incorporate security into your operations. So those are things that I won't be able to cover, but are worth checking out and looking into. So to give some background on security and how we should be thinking about security, I like to say security is a spectrum. Other people say describe it different ways, but the idea is just basically that security is not like a one-size-fits-all type of thing. It's not like a linear type of, one value that you can increase and get better at. It's like many things. You improve the security of the runtime area. You can improve the security of your network, improve the security of your host. There's many aspects to even those things. And so you have to think about it in a very holistic way. Another thing that I wanted to emphasize also, that because of that, attackers can kind of pick the targets that they attack, and they can pick the avenue of the attack. So this is kind of encapsulated in the idea of the attacker's advantage or the defender's dilemma, in the sense that attackers can pick the time and the actual physical method of attack, and so you have to be vigilant and think about things in a very holistic way. You can't just focus your security and improve security on one area, because they can go pick the weakest link and use that in order to circumvent the things that you worked really hard on. Another thing that we want to talk about is just to, in each of those aspects that you improve in your security, you want to provide as many hurdles as possible. So this is the idea of defense in depth. So This basically means you want to make the attacker have to do as many things as possible, find as many vulnerabilities as possible before they actually get to something interesting like user data or credit card numbers or whatever. So this is the idea of layer of defense in depth. So like folks who are developers are pretty used to doing things, not repeating yourself, like using libraries and making it so that you don't have to modify multiple pieces of code when you make modifications. But security is kind of is not like that. What we want to do is we want to, even if one area is secure, we want to add extra layers of security. So even if that one layer breaks down, we have another layer that's there preventing the attacker from getting at what they want. So what we want to do is make sure that things like the runtime, the node, and the network, each of those has multiple layers of security, and then the attackers have to circumvent multiple pieces in order to get at user data. And then in each of those aspects, limit the attack surface. So this means make it so that give the attacker as few options as possible for circumventing that layer of the security. And then finally, as part of the Security 101, just to get get it in your mind, is the idea of least privilege. And this means giving applications or giving some part of your system as little privilege as possible. So that means only giving it the privileges that are necessary for that application in order to run. Otherwise, if an attacker is able to compromise that application and steal those credentials, or otherwise execute code as that application, then they only have the privileges that application was originally given, and not extra privileges that allow them to do more and penetrate deeper into your cluster or your system. So now that we've kind of level set, I'm going to talk a little bit about go through some scenarios and then how to kind of mitigate those scenarios. And so as part of that, I'm going to use a really simple sample application. You don't really have to think about this too much, but it's just an application that has a few services here in the cluster. It has a web front end and a message service. So this is a guest book service where the user can enter their guest book message, and that gets saved to our Redis database on the back end. But the web front end does that through our message service. We also have an authentication service for our user service, which is used for authentication. So the first kind of a scenario that I want to talk about is attacking the Kubernetes API server itself. So one way that an attacker might try to attack your service might be to attack the Kubernetes cluster API server in order to try to get privileges on the cluster that they can then use to further attack the cluster. So by default in Kubernetes, each pod gets what's called a service account, which then has privileges attached to it. And by default, prior to, I think it was 1.6 or 1.4, those service accounts had full access full access to the Kubernetes API server. So you could use the credentials for that service account to access the API server, and then create objects and read objects. So one thing you might do is if you're able to say use a vulnerability in the front end, say the front end allows you to read an arbitrary file off of the file system, you could read out that token and then use that to attack the Kubernetes cluster. So the number one thing that you absolutely positively need to be doing is to be using areback. So this is, as I said, has been the default for a while, but it's still possible to disable it. If you don't know what it is, maybe you decide that you're going to disable it. This slide is basically here to say don't ever do that. This is absolutely positively necessary and table stakes for running a cluster in a secure way. And what this is role-based access control. So this is essentially a way of giving roles to users, and associated with each of those roles is permissions for interacting with objects in the Kubernetes API. Those permissions look something like a verb and a noun. So it's like get secrets or update config maps or watch things or watch object, that kind of thing. And so and then you give a number of permissions to a particular role, and then you can give that role to a user. And areback can apply to a namespace, so you can segment those permissions or those roles to a particular namespace, or you can create them cluster-wide. So the kind of data model looks something like this, where you have a user that can have many roles. In this case, we're using cluster role bindings, but a simple role binding would be one that acts on it is namespace specific. In this case, it would apply to the whole cluster, but a user can have multiple roles, and associated with that role could be multiple permissions that are part of that role. So another way to help kind of mitigate attacks on the cluster is to limit where your API server can be accessed from. So this is typically done if you're running like on-premise or whatever by normal firewalling rules or restricting networks access through however your network or whatever mechanisms your network allows. If you're using something like GKE, you can use the master authorized network feature in order to limit the IP addresses that can access your API server. But the idea is basically just don't give access to your API server to, like, say, the global internet or wherever, because you might want to make sure that only certain places or certain parts, certain people can access it, or you can only access it through certain channels. So either from inside the cluster itself or from inside of your corporate network, something like that. Another way to kind of like help mitigate some of the issues might be to implement network policy. So in this case, I'm mitigating number 3, which was on our previous slide here, which is further attacking the cluster by like talking to a service directly that we weren't normally talking to. So here we usually normally would go through the message service, but if an attacker is able to take control of our front end and execute code, then maybe they can attack another part of the cluster. And so network policy is just a way of specifying essentially firewall rules, but doing it in a Kubernetes native way. Instead of attaching firewalling rules to the host, you would attach it to, in this case, to pods. And what we use is the normal kind of label selector way of doing that by saying that using this pod selector, and that matches the pod, that matches a certain set of pods, and those pods are the pods that this network policy applies to, and then you can specify either ingress or egress rules on those particular pods. So in this case, we're specifying that our ingress into the Redis pod can only come from our message application. So you can't access via the network the Redis pod directly from anything other than the message service. Another scenario that an attacker might go through as they're trying to attack a cluster is to attack some of the cluster components. So in this case, we're going to talk about XZD because that's particularly vulnerable. But any other components running the cluster might have, you might think about similarly. And these are things that the API server needs or the API server itself. You don't want to allow access directly to talk to, locally on the local files on the API server or directly to XZD itself. And the reason why you don't want to do that is because XZD stores the objects in your Kubernetes APIs that your Kubernetes API server saves. Like this is your object store for it. And so if you can access it directly, there's no kind of you're basically bypassing all of the areback rules that we just talked about. And so you can read off the secrets in the API. You can add new objects to the API as well. So you essentially get full access to the cluster by being able to write XZD, and you get full permissions for reading by being able to read from XZD. So in order to mitigate that, what you want to use is you want to be setting up XZD to require authentication, and you want to restrict the access to XZD on the network using normal firewall rules so that it can only be accessed by your API servers and not from the cluster. You don't want to provide your XZD that you're using for your API server to the cluster itself as a service, because that just makes it extra vulnerable from attacks that are coming from inside the cluster. Another thing you can do is encrypt the data in XZD. So this is the encryption at rest feature, where the API server, the data that the API server saves in XZD is encrypted. So that if you try to read it directly from XZD without the key, you'll just get encrypted data and you won't be able to read it. This also makes it so that you can't effectively write data because you would need to know how to encrypt the data properly in order to write it. Right. The next scenario that I want to talk about is getting access to the host. And this essentially is breaking out of the container environment and then attacking other pods that are running on the host itself. So in this case, we're assuming that there's a vulnerability in our web front end. So our attacker makes use of that vulnerability and is able to execute some code inside of that container. But one thing that you should note about containers is that they're pretty effective at providing a good reproducible environment for applications to run in, but they're not terribly effective at sandboxing code that attackers, or untrusted code that attackers might be running. So if an attacker can run code inside of your container, it's not a terribly effective sandbox to prevent you from further escalating inside of the cluster. And that's because you can take advantage of kernel bugs that might be on your host machine or any other type of vulnerabilities in your Kubernetes cluster. You may have followed some of the CVEs that have come out about Kubernetes, and many of those allow you to break out of a container. And so it's something you need to be thinking about if you're going to be running untrusted code. But in this case, we have an attacker that is able to execute code, and so he breaks out of our container. And the things that he can do at that point are read the data for other pods that happen to be running on that host. So any secrets that are attached to those pods are things that he can read and then continue to further attack the cluster. Also, the attacker could then read the credentials of the kubelet and then talk to the API server as if it's the kubelet in order to further read data or try to escalate privileges in the cluster. So some of the ways that we want to mitigate that, first is to try to make it so that it's harder to break out of the container in the first place. And one way to do that is to run your applications in your container as a non-root user. So this makes it harder for you to break out of the cluster or out of the container, because typically you need to have root access inside of the container in order to break out of the container itself. So this just adds an additional step that an attacker would have to circumvent before they can even break out of the container. Another good thing to do is to have your root file system be read-only. And the reason for this is that if you have bugs, say, in the application, that maybe a user can upload files or something, and the application has a bug that allows them to determine which directory that they upload to. So they could, say, upload and overwrite a binary that's on your root file system, and then trick your application into running that binary and effectively get code execution inside of the container. So this will prevent you from overwriting binaries that you don't expect to be overwritten. Another is to set this allow privilege escalation to false. So this basically effectively sets the allow privilege escalation bit to false for your application, which means that if an application execs another application, runs a shell or something like that, then that particular application will not be able to have privileges that are greater than the application that's executing it. So this makes it a little bit harder to be able to get higher privileges. So doing all of those things is a recommended good practice. Another idea is to use sandbox pods, and these are effectively to make it so that you can run untrusted code. So if you're writing code on a user's behalf or something like that, this is something to look into, where the sandbox pod essentially makes it so that, or the sandbox runtime provides the container an environment that's much more separated from the host, and so is very hard to break out of. So this is like if you're running code on people's behalf, or like you have an environment where you can't trust the code that's being run in the container, this is something to look into. So examples might be Kata containers or gvisor. And gvisor effectively does this by running a user space kernel that is separate from the host, so that the application, even if the application is able to execute code as the kernel that it's using, it's still kind of trapped in that sandbox environment. Another thing that you can do is to use seccomp and apparmor. These effectively add extra layers on top of the existing layers that, the namespaces and C groups and things like that the containers make use of. And so a container, if you think about it as like being in a jail, like seccomp and apparmor are additional layers that go on top of that in order to further lock down the application and provide additional rules that you can set. Very unfortunately, seccomp is still not kind of on by default in Kubernetes, and so if you do nothing else, you should be setting this annotation on your pods in order to make use of the default Docker seccomp profiles. Otherwise, your containers are running without a seccomp profile attached to it at all. Apparmor, thankfully, if it's installed, is used by default, but you can ensure that it's set by adding this annotation, or if you want to use a custom profile, you can set that here in this annotation. And then SE Linux can be done as part of the security context in your pod, so you can set your SE Linux levels and other options there. And then finally, like to mitigate kubelet, the attacks on the kubelet, you want to be using the kubelet areback mode, which is a special areback mode so that that's set up so that the kubelet can only read things that are relevant to that kubelet. So it can't read secrets that are attached to pods that are not scheduled on that particular node. So if a pod is scheduled on a different node, it can't necessarily read the secrets from those pods. It can only read the secrets for the ones that are scheduled on that pod. Another thing to do is to rotate the certificates so that if your kubelet certificates are stolen, that those can't be used forever. They can only be used for a limited amount of time. Another thing to do in order to kind of set policy and make sure that everybody's on the same page when they're creating pods is to use policy. And the current best practice for doing that is to use Open Policy Agent, which is a way of kind of gating the type of options that you set on your pods. So this allows you to set policy like all of our pods in our cluster or in this namespace or whatever have to be run as non-root, for instance. So like some of those security context options, you can use Open Policy Agent to make sure that people have to set those fields, and they can't just willy-nilly create pods in the cluster that don't have proper security set up. And the last thing that I want to cover in the minute or so that I have left is sniffing traffic on the network and doing things like request forgery. So this might be like listening to the traffic that's going back and forth between depending on how your network is set up. You might be able to do that if you had code execution inside of a pod. And getting information about what's running inside your cluster that way, and also being like sending requests to another service as if you were another service. So like basically just forging requests and making services do things inside the cluster that you wouldn't normally want to be allowing. And this is where like kind of service meshes really help. So things like Istio, I'm going to talk about how Istio works, and will help in this regard. And what that does is it adds a proxy layer between each of the applications. So like each one of these applications would run with a sidecar proxy, and that proxy enforces essentially security policy. So that might be end-to-end encryption in order to encrypt the data that's running on the network, as well as each application and service will run with its own identity. So you can set policy and say that this application can talk to this application, but it can't talk to another application. And those, the requests that are made have a proper identity set so that you can't forge a request for another service if you aren't that service itself. So that means that like, if we are, say, our web front-end service, we can't just send requests to Redis or the user service or like other services without having proper policy set. The sidecars on the user service here or the Redis service will enforce the policy that's been set up on the cluster and will reject requests that aren't properly authenticated. All right, so I want to close now by just giving some general tips. One is just to update your Kubernetes cluster early and often. I mentioned that Kubernetes itself has many CVEs that come out on a regular basis. Every quarter there's generally one or so. And so you want to be updating your Kubernetes and make sure that your Kubernetes, like even if you don't update to the very latest and greatest, that at least on the major version that you're running, updating to the version that has the patches backported to it. Also, don't use like admin for your day-to-day work, like keeping admin credentials on your laptop and things like that. Be a little bit mindful about where the credentials are for interacting with your cluster, and don't lose them. Don't leave them at conferences, that sort of thing. Try using things like KubeBench and other benchmarking tools to like kind of check your cluster and see what sort of, kind of scan your cluster essentially and see what sort of things might be problematic. And you can get hints that way about how to fix some things that might be potential security vulnerabilities. And then finally, use things like managed services like GKE that have a little bit, that aren't necessarily perfect, but have a little bit more thought put into them in terms of like their defaults and the options and features that are available to you in order to secure your cluster and operate it. So I'll stop there and say thanks. I don't think I have time to take questions here, but I'll be around outside and I'll be around at the Google booth later today, the Google Cloud booth. So if you have questions, you want to talk and chat about security or GCP or things like that, then I'll be around to do that. Thanks a lot.